think number 1 is negative 3.5 minus e over 1/2 minus pi over 4.
I forgot about
Just, full disclosure, I tried to make number 1 sort of look like a L'Hopital rule, kind of, but it wasn't really a L'Hopital's rule. So I did try to mess with you a little bit to see if you would just assume that it's L'Hopital's, but it's definitely not. So, and then number 2, I remember this from last class because I looked it up. For number 2, did anybody get a velocity of like negative 2.99 something? If you did, you were just in degree mode. And you should have been in radian mode. So you just want to be careful that in this course, because everything's going to be in radians, like pi t radians for the input. So you got to be in radian mode in this class. And I know you're just getting used to using the calculator in here. We'll want to transition over that. So before a quiz or a test, I'm always going to say in radian mode, please check, right? Because all you physics folks probably doing the other one. Right.
Why is it not, for the first one, why is it not negative 3.5 minus e to the 3 point, or you were at 5, but.
It'd be e to the first?
It would be
because you're evaluating the limit as x goes towards 1. And so really it comes down to a direct substitution. I'm just going to be substituting a 1 in for the x. So it would be e to the first, which we just write as e. Okay.
And then if I said 3.4 instead of 3.5, is it count by 2s?
Let's see here. F of 1.
Well, but then it wouldn't go with the negative 1/2.
Yeah, so I think that's a pretty important thing there, Ty. So like the y-intercept, I think is pretty clearly negative 3, and the slope that you got for your f prime is negative 1/2. So if you start at that y-intercept negative 3 and you go down 1, right 2, if you follow that pattern, you are at negative 3.5.
I thought isn't it going up by 2 slope?
Sorry?
For everyone that has black, or like thin black lines, isn't it going up by 2, or like 0.2?
0.25, I think. And there's 4 of them. There's 4 of them between each square.
Oh, yeah, you're right.
Yeah, that's okay. All right, any other questions on 1 or 2?
If we used our calculators for number 1 and like got a number.
That's fine. I did you get to my answer and then use the calculator?
Kinda.
Could you have gotten to my answer without a calculator?
Yeah.
Then you're fine. Like I try really hard on all of these examples we do in our notes, and every now and then like one will slip past me. But I try really, really hard that if I think that the calculator should be active, I'll put calculator active.
Okay.
And if I think it shouldn't be a calculator, I'll just leave it blank. And that means typically that I'm intending for you to do it without a calculator. Like I said, every now and then something will slip past me. I'm like, oh gosh, we probably should use a calculator there. But I'm going to always default to not using the calculator. Okay, so here's an answer for number 3, or I guess a couple of answers for 3. So your graph should roughly look like that. I realize that all the turnaround points were not like precisely defined, so there could be a little bit of wiggle room left and right. But basically we're looking for the same basic shape, and all your zeros should be really close to where mine are. All the positives and negatives stretches should be, again, very close to where mine are. I don't think I'd ask a quiz question quite in this format because it's a little imprecise. It's kind of hard to mark it right or wrong. As long as you're looking really close to mine, I think we'd be in good shape, especially if it makes sense to you why you got what you got and why I have what I have. Any questions on 3? Okay. Maybe just maybe one last second to think about it. Okay, so we're going to do an exercise here in our class we haven't done yet. We will do more of these in the future. I just wanted to carefully define what this is. This is called think, pair, share. Oh, come on, there we go. So I'm just going to leave it there at the bottom for a second. So think, pair, share. So here's what this means. Very specific. So for about 2 minutes, I want you to think carefully about the question that you're about to be asked. Okay? I want you to think about it by yourself. I want you to write stuff down by yourself. And after 2 minutes, after you've had a chance to think and write a little bit, I'm going to have you pair up with a partner, or in some cases, triple up, as the space and tables dictate. And I want you to pair up, and I want you to let each other know. Here's what I wrote down. Here's what I think is important here. And then after about 2-3 minutes of that, I'm going to have you guys share out to the group as a whole, and we'll write a bunch of stuff down. We'll hopefully come up with some really nice conclusions. To the answers to our question, it says, carefully look at the graph of f of x below. Please write down everything you know to be true about the graph of f of x on the interval shown. Then compare notes with your partner, and then we'll share together. We'll get some key takeaways at the end as well. So let's take 2 minutes right now. Think and write by yourself what you think is true about the graph of f. And remember, you're in a calculus class. So including some thoughts about f prime. Also, if those happen to come to mind, then they're a pretty good idea too. About a minute or so, a little less than a minute. Keep thinking. Write down everything you can think of that's true about this graph. F of x, f prime of x, any of the features you see that seem to stand out to you. Let's do a little bit of comparing, and maybe somebody thought of something you didn't, or maybe you thought of something they didn't. Let's get it all down, let's write it out. Like you see at the bottom there, it says key takeaways. We'll try to summarize the big things I want you to be bringing away from this activity. So try to use all that space above. Pair up, pair.
Oh, yeah, you're right. I know,
Why is that negative 2?
yeah, or it could be like,
Yeah.
yeah.
Okay, good. If I walked over here, I'll just say,
They were thinking about mine.
is anybody awake? It's very loose.
The y, I had the zeros.
No.
Yeah, I had the pills on the zeros. I had that prime
We do a lot of
0,
electronic
0. I said that it's continuous on this interval. I said that
No, definitely not. You need to know actually what's
non
making the graph. Are saying like the radius is the direction. That's really good to have a sense of it because you can look at it and be like, that's one of those roses, like that's useful. You can still be successful without that. But
Yeah.
you gotta be like, oh, it's one of those opioids. That's useful. It doesn't have to be like a perfect graph. You just have to be like, oh, that's kind of has the point there. Like, or is the one that has like the extra little loop inside. Like if you even suspect that that might be the case, that's actually a feature.
It's like the sine
Yeah, it's gotta be R squared when it was. Yeah, essentially, yeah, it has to be R squared. Yeah, don't worry, whatever you do, don't stress about
I never thought about it.
Okay, what I'd like to do now is hear from you guys. We'll just kind of go table by table and take maybe a key takeaway from each group as to what you think is noticeable and true. So if somebody, we'll just, like I said, go one table at a time. If you want to go first, just raise your hand. I'd love to hear what you all have to say about this. Go. Share something. Yes, Allie.
Well, there's at least one minimum.
I agree. There is at least one minimum. Totally agree. Keep going, guys. Let's get another table involved. Go, Cole.
I see a vertical asymptote at x equals 1.
The other class was really adamant about that.
On the interval, I guess.
And I don't know if there is a vertical asymptote at 1. There might be. It looks like there could be. I feel very comfortable saying there is for sure a minimum because I can see it right there. It appears that there could be a vertical asymptote at 1, but could there be a vertical asymptote at 0.99 or 1.01? Or could it be that there's no vertical asymptote at all? It's kind of hard to tell. We can't tell what's going on past that. So I don't want to speculate on stuff outside of the realm of the graph that I'm not for sure about. You might be right. Brendan, you had your hand up.
Yeah, well, I'm gonna just put my hand back down. I was gonna say that there was a vertical asymptote.
Oh, it looks like there could be. Again, yeah. Okay, I want to get a bunch of different tables. We'll come back, though. We will for sure. Anna, go.
I said that it's not 1 to 1, which means
Okay, not 1 to 1. So the inverse wouldn't be a function?
Yeah.
So it's not 1 to 1 because it would fail the horizontal line test. Brendan, you're back.
Yes, I am. Fx has two x-intercepts.
Okay.
Negative 1.25 and 0.75.
Has two x-intercepts, 1.75, negative 1.25, you said roughly?
Yes.
I can buy that. Thanks, Brendan. Shay, go.
The function is continuous.
Sure looks that way, at least on the part we can see. Yeah. So f of x is continuous, at least on that interval. You guys, your table's gone. Let's see, your Allie's table. You guys haven't gone yet. Share out. What'd you come up with?
We said it's like continuous, and we said the asymptotes too, but.
So now we're maybe backing off the asymptote.
Yes. I don't know, something about maybe like not differentiable, maybe just have like two different f primes.
Why would it have two different f primes?
Okay, yeah, it's not a sharp point, so sorry.
No, it's okay. If I ever question you, it's not that I'm like making a point of like you're wrong and I'm about to show you why. A lot of times I'm just like, why? I don't understand what you're saying. So don't take it the wrong way. Okay, so you're like, there's no sharp points. Anything else?
The graph of f prime of x is, it goes through the origin, and it's like down and up.
Okay, so the graph of f prime goes through the origin. Interesting. So this is the first time anybody said anything about f prime, right? So take us a little further. Like why would you say that?
Well, because the minimum is at x equals 0, and then
So minimum at x equals 0. So I'll piggyback on that a little bit. So minimum x equals 0. Keep going.
and then on the left of that, the slope is negative, so it starts in the negative direction and then it goes up to the positive.
Whoa, so she just like loaded us up with a ton of stuff right there. So she said to the left of the minimum, you said the slope is,
Of f of x.
slope of f is negative, and to the right,
It's positive.
be careful of the word it,
The slope is positive.
slope of f, yeah, is positive. Whoa. Okay. This is a place, at least for today, we want to go. So stop and think about it. When she said, I'll write this down. The slope sorry. The slope of f is positive, and for x greater than 0, or the slope of f is negative for the left side. Pretty interesting observations, right? So here in calculus, if we were to say the slope of f, what would be a different way to say that? Derivative of f, f prime, dy dx maybe. I think I like f prime in this case just because it's like nice and succinct, but all those are true. Couldn't I say f prime is positive for x greater than 0? And then by the same kind of thinking, f prime is negative for the left side? Now I want you to make one more connection. This is really, really good. If we go back over here, like so, all the stuff over here on the right that I'm putting in a yellow box, it's pretty much all about f prime, isn't it? The slope of f, f prime is positive, all those things. If I go back over to the left side, everything is more or less about f. It's all good. I'm going to highlight a part of our graph here. So kind of go a little bit with what Kendall just said. On this red highlighted part, how would you describe the graph of f? Say again? Decreasing, yeah. So I'd say f is decreasing for negative x values. So on the left side of the graph, f is decreasing, and that's more or less what you said, right? The leap is not very big. And then, of course, on the purple part up here that I'm drawn in, you would say f is what? Increasing, yeah. So what I would like for you guys to do here is make this connection. Do you see how this I wrote it in a bad order here. Do you see how the two green pieces go together, the two green statements? F is decreasing on the left side. F prime is negative on the left side. And then maybe you can also see how the two orange parts also go together. F is increasing on the right side of the graph there. F prime is positive on the right side of the graph. Nice work, by the way. You guys came up with some really nice observations. It's good. So can I show you the key takeaways? And I want to try to tie this all together, and we'll do, I really, really hope we can get to 3 examples. The third one is awesome. The other 2 are really good too, but the third one will make you think a little bit. So here we go. Key takeaways. If f prime is positive, f is increasing. If f prime is positive, f is increasing. Let's take 1 second and think about why this connection is true. What is f prime describing about f? The slope. So if you say if f prime is positive, isn't that just a quick way of saying the slope of f is positive? Well, then it would naturally follow then that f would be increasing, right? Okay, so if that makes sense, then maybe we could say if f prime is negative, what would our conclusion for that be? Say again? What is decreasing? F is decreasing, yes. F is decreasing. And there's one more that was hinted at. I think it was the first thing that Kendall said there. She said the graph of f prime goes through the origin. So if a graph of something is going through the origin, it's going through the x-axis, right? And what's the value of something right there when it's going through the x-axis? 0. Some of you might have made this observation, but Kendall kind of short-circuited you with hers. Did anybody say that there was a horizontal tangent line right there at x equals 0? Yeah, so horizontal tangent line has what sort of slope? 0. So couldn't we say that if f, let's try that again. If f prime equals 0, then we would say f is constant. Even if that constancy is only for a single point, like in our graph, at one point in there, f prime was 0 because there was a horizontal tangent line. Okay, so those are your big takeaways. And honestly, if you can really start to absorb these and say, oh yeah, f prime is talking about the slope of f. So if f prime is positive, that means that f is increasing. If you can really take a hold of that, you're going to do great. I mean, at the core, that's all we're doing here. We're comparing f prime's value with the graph of f. If we can make that comparison, we're in good shape. Okay, so I want to do a little bit of back and forth stuff with our first example. I'm going to turn you loose on the second example, and I'd love to turn you loose on the third example if we can get there. So let's do our best. So here is example number 1. Example number 1, kind of to Shay's question earlier, example number 1 is absolutely a no calculator question. Okay? There is, for those that are maybe prone to hope unrealistically, in no way, shape, or form would I ever ask you question number 1 and make the calculator active. Because if I did, all you got to do is graph it and you'd show absolutely no calculus knowledge whatsoever. Like, hey, it went uphill right there. That must be the answer, right? So this definitely be a no calculator question. Here we go. I'll read it out loud. Identify the intervals on which f of x is increasing, or where f of x is decreasing. If your function is that f of x equals 27x minus x cubed, we're supposed to be justifying our answer. I've never used those words before in our class. Justify your answer means, in a very strong sense, give good reasoning for why you said what you said. Like really rock solid reasoning. So we're going to talk about that in the coming days about what rock solid reasoning justification really is. Okay, so based on what we just talked about and what you know about f of x and so on and so forth, when you see that we are looking for where f of x is maybe increasing or decreasing, what's a thought that pops into your head? What might we be looking for? X values, those could be important. Keep going.
F of x.
Oh, f of x is
Derivative.
Derivative, f prime. I heard a couple of f primes. Wait a minute. So if I could find f prime, what would I do with f prime? What would I be looking for?
When it's positive.
When f prime is positive or negative, because think about it. If I could prove that on a certain interval f prime was positive, what would I then be able to say? F is increasing. But if I could find a place where f prime was negative, then I could say that f is. So finding f prime makes sense? So here we go. I'm hoping that at this stage of the game, for you guys to find this f prime wouldn't be too hard. 27 minus 3x squared. Let's go back to what you just said. Said, I want to figure out where f prime is positive, perhaps, or where f prime is negative, because that would be the key to finishing this easily. If I'm trying to figure out where f prime is either positive or negative, what might be a really smart first step for me to get towards that goal?
Equal to 0.
Yes, because doesn't 0 divide the positives up from the negatives? So if I could find where f prime is 0, this would be very helpful. So a word to the wise, if you intend to set something equal to 0, write it on your paper. Don't just do it in your head. Okay? So you need to actually take your pencil or pen and write equals 0. Once you write that down, there is a lot you can do with it. But until you write that down, there's not a whole lot we can do as far as solving anything or getting to where we want to go. I'm so hoping that this is a pretty quick equation for you to solve. When you solve this, did you guys get x is equal to plus or minus 3?
Yes, sir.
Good. Awesome. So I want to introduce to you guys a graphic that I'm pretty sure you've seen before. I've asked your pre-calc teachers if you've ever done anything like this. I call this a sign chart. And I think in past years, you guys use this to test out values of f. It's like a little number line with some key numbers on it. And so, you know what, I'm gonna redraw that. Kind of don't like where that ended up. Yeah, I'm just going to draw a little number line here off to the side. I'm going to label it with the label f prime because that is what I am testing out. I'm trying to figure out what's happening with f prime. And like I said, I call this graphic a sign chart. And this is just a helpful visual for us to get a sense of where we need to finish with this. On this sign chart, I'm going to put my 2 key numbers. What are my 2 key numbers where I might get some change? Plus or minus 3. So negative 3 and 3 go on the sign chart. And by doing this, I've created some intervals. How many intervals have I created? There's 3 separate intervals. I'm going to color code them just so I can refer to them easily. There's an orange one right there. There is a red one right there. And I'll have a purple one right here. So I got 3 intervals. Orange, red, purple. And all I really need to do here is test out those intervals to decide, is f prime going to be negative in one of those intervals, or maybe 2 of them, or all of them? F prime going to be positive? Once I have that, I'll be able to finish pretty easily. So anybody have any ideas on how I could decide, for example, the orange interval? Is f prime going to be positive in the orange interval, or is it going to be negative? What can I do? Plug in what? Negative 4 makes sense, negative 5. Any numbers to the left of negative 3. So if I tried this out, I would say f prime of negative 4. I'm plugging into f prime, right? Because I'm interested in what is f prime doing. Did anybody use this number? Did you get negative 21? I think that's it, isn't it? 27 minus 4. Wait. Yeah, 27 minus 48. Negative 21. So that means on that orange interval, we could label that with negative, right? Because it's all those values for f prime would be negative in the orange interval. What number would you plug in for the red interval?
0.
0 makes a ton of sense. F prime of 0 would be?
27.
What's the most important thing about 27? It's a positive number. And then you could also test out this interval over here with, I guess 4 would be a pretty logical choice. When you plug in a 4, don't we go back to negative 21? Okay. So you get this lovely sign chart. So this has this has pushed us to the brink of knowing how to answer this question, hasn't it? I want to let you know, a sign chart like this is not justification. I want you to think of justification almost like how a lawyer would try to prove that someone is not guilty or someone is guilty. We want to directly and precisely state what we're saying. So I can't imagine you would think that if my reasoning was, hey, f is increasing from negative 3 to 3 because check out my graph. Does that sound like that much of really solid reasoning? I hope you don't think so. It's not. It's not good reasoning. Or it's not sufficient reasoning, I guess. So let me give you an example of how I would like you to finish this, justifying your answer. So here we go. I would say f is increasing. You can just use INCR for increasing. We'll all know what that means. F is increasing on the interval, negative 3 to 3. Because. So I've answered the question. I've said, hey, f is increasing on this interval. Blake, don't get too distracted by that yet. I think I know where you're going. You're talking about the or equal to's? No?
Oh, I know.
Okay, well, it's okay. All right, okay, I just want to make sure I wrote it down right. I think I did. So I've answered the question, but I haven't justified anything yet, right? I just wrote because. This is where I'm going to justify it. F is increasing on that interval because. Any guesses on how I could justify this? F prime is positive. Can I show you a really bad justification? That was a good one. Can I show you a bad one? Check this out. What is so terrible about that? It is way too vague and ambiguous. I don't really totally understand what the word it means in this case. Are you referring to F? Are you referring to F prime or something else that I don't even know about? So we want to avoid the word it like the plague. And as a matter of fact, wouldn't you have to say that writing what I'm about to write is actually faster? Check this out. I'm going to erase it is positive, and I'm going to write because. Isn't that faster? That's even better. It took you less writing, and you said it correctly. So we'd say because f prime is positive, technically should be greater than or equal to 0 on the interval from -3 to 3. Okay, and then the other one, we were also asked where is f decreasing? So of course there's not just one interval where f is decreasing, right? There's two. So I'd say f is decreasing on those two intervals. It would be -infinity to -3 and 3 to infinity.
Can you use it doing like the brackets and parentheses?
Sure. Totally. Because what would be, so there's my answer, but what would my justification be? Because why?
F prime of x is less than 0.
Yeah. F prime is less than or equal to 0. And I'll just put on those intervals. I don't have to rewrite those. If I don't want to, I could just refer back to them as those intervals. Something like that. Okay. What do you guys think? It's a really big step where we're going here. The justify thing is a big deal. The increasing, decreasing relationship with f prime is a big deal. Trying to take this in baby steps. Hopefully it's working. If it's not, let me know.
Why is it like less than or equal to?
Yeah, so people get hung, it's less than or equal to, right? So I don't want to spend more than like 45 seconds on this. Math people fight about this all the time, but it's been definitively proved based on the definition of increasing or decreasing. Technically, increasing can only happen between any 2 points. And so if you include the endpoints, if you go all the way up to -3, you can say for sure that f increased all the way up to that point to where it started to turn around, right? The high point is definitely, the high point or the low point will be at either -3 or 3. But if you pick any point on that interval and you compare it to that low point, you're still seeing a decreasing pattern. Even if you pick the point right next to it, you're still seeing a decreasing pattern. So we typically, other than certain application questions, we never will refer to increasing at a point. We'll always refer to increasing or decreasing over an interval. Yeah. When I say that mathematicians get in fights over this, I'm not exaggerating. Not fist fights, but like math fights. Maybe they get into fist fights too. That would be pretty hilarious, perhaps. But, no kicking or hitting, just words. And
If we
numbers.
were using,
And by the way, I want to say this. So a follow-up to your question, Brian, is this. I've tried to present a rigorous, like technically exact way of writing it. If you didn't include the little or equal tos, I'm not going to take any points off for that. To me, that's like, you like say on a quiz, you know, where you like everything's got to be perfect. If you had open intervals on all those, I'd still give you full credit. Definitely.
some mathematicians agree with this.
But all the ones I've ever seen have been argued down, and they're finally like, okay. I just don't want to make that the thing. Like if you can connect f prime being negative with f being decreasing,
Then you got
yeah, we're excited, right? And I don't want to be like, well, should have been or equal to, and you didn't. Yeah, to me, I don't want to go there. And the AP folks don't want to go there either. So. Okay, so let's do number 2. Number 2, this will be where we finish. Unfortunately, we are not going to get to number 3 today. I will try, I don't know. We might have a chance we might come back to number 3 because I know our class on Monday is a little extra long. So we might come back to number 3. It's a really good question. So let's finish with this one. Number 2 says, use the graph of G prime to determine the intervals on which the graph of G is decreasing. And then those 3 words justify your answer. give you a moment here to think this through, and then we'll tie it up before we go.
Is there like a sharp point here?
I would say at 5, it certainly looks like there's a pretty sharp looking point there.
Okay.
Agreed? Yep.
At 2,
And really, even
And
at
at zero.
even at 0, you could maybe make that argument. Yeah. I think I piecewise this. I think you can. Yeah, I didn't make the transitions very smooth.
All right.
I definitely didn't find A and B to make G prime differentiable and continuous everywhere, right?
Yeah.
Yeah.
So.
I do want to get you your quizzes before you go. Before we wrap it up, I'll get these in your hands.
I thought I was going to kill that quiz, and I didn't. Confused.
From negative 2.
Okay, so I want to, in classic form, I want to show you what a lot of people will say and they're wrong. Let me show you a classic incorrect answer to this. Had a lot of folks look at a question like this over the years, at least at the start, and say, oh, this isn't too bad. And then their answers are these. And maybe you wrote that down. And if you did, you're in good company. There have been plenty of people that made this mistake and went on to make an A and a 5. That's no problem. If somebody were to make this mistake, they are mistaking, say it, Ben?
G prime for G.
Yeah. That's a graph of G prime. And those intervals are places where G prime is decreasing. And that actually is a thing that we'll find. But it's not what this asked for. That makes sense? It's not what this asked for. This asked for where is the graph of G decreasing. So this will be the last thing you'll hear from me. G would be decreasing if G prime is negative. And since that's a graph of G prime, where would negative values show up? Below the x-axis. So I would be looking for all these values down here. So my answers will be G is decreasing on -2 to 1 and 6 to 7. Because why? G prime is? No?
Less than 0.
Yep, G prime is negative on those intervals. And that last little piece would be your justification. We've got it all tied up.
Oh, I just don't think of that.
Okay, we'll keep practicing. Have a good weekend. Don't forget to be ready for Mr. L'Hopital on Monday.
Yes.
Le Hopital. Yes, be ready for him.
I'm slowly now figuring out how that works because